So this is power rules with positive exponents when we're dealing with quotients. So that means division. Okay, so, and this is kind of the third time we've mentioned this one. I like to say as mentioned above. So exponents are used to write repeated multiplication. Don't forget that. When I have, if I look here and I have x to the fifth power, it doesn't mean x times 5. It means x times itself 5 times. So if I were to expand it, it would be x times x times x times x times x. So now we're going to take a look at two methods for exponent division. First, let's practice with some multiplication. So with this first one, we're going to multiply or distribute the exponent. So when I have a power raised to a power, we just did this on the last video, is power of a power. I have to kind of distribute that power to each piece. So I have negative 2 to the fourth power, and then u, which had a 1 exponent, to the fourth power. So you can see the power of a power happening here. Whenever I have that, I'm going to multiply the exponents. I also have to do it to the denominator. I don't just get to ignore that guy. So I had v to the fourth power, and now it's v to the fourth power to the fourth power. Okay, so we're going to go ahead and simplify this. So negative 2 to the fourth power is 16, because that's negative 2 times negative 2 times negative 2 times negative 2. And 4 negatives are going to cancel each other out since it's even, and it's 16. 1 times 4 is 4, and then 4 times 4 on the bottom is 16. So this is simplified. There's really nothing else I can do with this piece. It just wanted me to rewrite it without parentheses here. Okay, so there's nothing else to move. There's nothing else to simplify. That's as far as we can go. All right, so on this one it says simplify yx to the fifth over y to the sixth power, x to the third power. So when I have like terms from top to bottom, and everything is being multiplied here, across in the numerator everything's multiplied, in the denominator everything's multiplied, well, I can expand and cancel. So here I'm showing you, these are all the pieces I actually have on the top. So I have 1 y and I have 5 x's, and I have 6 y's and 3 x's on the bottom. So I can actually go through and I can cancel 1 to 1 from top to bottom. So 1 y to 1 y, and then I have 3 x's to cancel from the bottom to the top. Okay, so then I just take a look at what do I have left. Well, I have 2 x's in the top left, and I have 5 y's in the bottom left. Okay, so with this one, before I move to the next page, you can also look at this as subtraction, which we will get into a little bit more. With the exponents, you can say 1 minus 6, and that's 5. And because most of them are on the bottom, it's going to stay on the bottom. And then 5 minus 3 is 2. Again, most of them were on the top, so it's going to stay in the top. So just like we used addition when we were doing the product rule, the quotient rule says we can use subtraction. You just have to make sure you're paying attention. Is it going to end up on the top or the bottom of the fraction? All right, so let's look at the next couple pieces here. So this is where we're looking at negative exponents, and this is another way to think of that subtraction rule too. So for any non-zero rational number a over b and any whole number n, we have the following rule here. So if we have a fraction a over b to the negative n power, then what that actually equals is the reciprocal. I flip it over, and it's b over a, and now n is positive. So a negative exponent doesn't actually mean that it's a negative number. What it means is that it's a small number. That's actually the indicator. But in a fraction, it means it's in the wrong location. So if it's in the top with a negative exponent, then it should be in the bottom. That's why we put the a in the bottom. And if it's in the bottom with a negative exponent, then we push it to the top. And then it becomes positive because now everything is in the correct place. So think of it as placement more than a negative number. It's just an indicator of wrong placement. And then you can distribute this n exponent to each piece, the numerator and the denominator. So this is, me just kind of saying again what I was saying. So think of this another way. A negative exponent means that the number being raised to the negative exponents are not in the correct position in the fraction. So if a number with a negative exponent is in the numerator, which is the top of the fraction, then it belongs in the denominator of the fraction, and vice versa. So we'll learn more about this, in section 4, moving forward, but this is kind of the beginning of it. So rewrite the following without an exponent. So that means not only do we have to apply this negative exponent, but we now have to actually evaluate what do we get when we work out these two numbers with that exponent. So remember, it's the same idea. A is 7 and B is 8. I'm going to flip it over so that the exponents are positive. So I distributed the -2 and then flipped it over. It's perfectly fine. It doesn't necessarily matter which method you use there, but you do want to make sure that you flip. This means that it should be in the numerator. This means it should be in the denominator. So we move them, and then 8 squared is 64, and 7 squared is 49. So now I've rewritten this without an exponent. All right, so this says rewrite the expression without using a negative exponent. So I will have an exponent, but it wants me to fix that negative exponent because we don't tend to leave it that way. So with this one, we have 4z to the -5th, and I'm showing you that it's over 1. Remember, all numbers are over a fraction, okay? So if I have the negative exponent here, remember, it just means it doesn't belong in the denominator, or the numerator, it belongs in the denominator. So I just take it from the top and I move it to the bottom. The 4 stays in the numerator. That does not have a negative exponent. That is separate from z to the 5th power. So that's it. We have rewritten it without a negative exponent. So that's as far as we have to go on that one. So I hope that helped, and I will see you in the next video.